Alright everybody, welcome back. So, as you recall, we've been looking at various transformations throughout the plane here so far. So for instance, we've looked at reflections, right? So for instance, with reflections here, you recall, it's something about a line like this here, you have a point like so, and you want to create something like this around here, where you're going across and making sure that we have a perpendicular bisector going on here. The reflection line is the perpendicular bisector. Of course, we can also have this idea of a point reflection as well. We can have something like this. Here's A, and with our point reflection here, we have our mirror being exactly halfway in between to create A prime over here. So we have this sort of thing going on as well. You recall we talked about that. We also talked about the idea of rotations here, right? So with rotations here, it's just a matter of spinning an object around a point here. So something like this, we want to make sure that we have an angle like so, keep these angles the same, and then we end up with A prime over here. So we have this sort of thing going on like so here, right? With a reflection, we had a flip, and here we had the same. We had a flip here. We're flipping over a line, flipping over a point. Rotations, we're flipping over. We're spinning. But of course, you can have the very simple transformation here, this idea of sliding, right? So for instance, if you have a point A here like this, or rather here's point A and a triangle ABC here, we can slide the triangle some distance and end up over here. So we get like A prime, B prime, C prime here. So we have this idea of what is known as a translation here. I think you've seen this before. We're just sliding from one point to another here. So just like with the reflection rotation, we have our notation for the translation here. So our translation notation, as you can see, looks something like this here. Of course, the big T here represents the translation. We have our again, we have our pre-image here. And then note that in this situation here, this represents, when you're doing a translation, the most important thing is where are you going? How far are you going? Where are you going here? So this represents what is known as a translation vector. Now, I realize the term vector is a little scary here. You'll be looking at vectors a lot more in physics and in higher level mathematics, but a vector really all it is just a direction here. So this really means +4 on the horizontally, and then -3 vertical here. All it really is just telling you what to do here. So in this case, shift 4 units to the right, shift 3 units down here. So it makes sense that if we have our point x comma y after we do our translation here, it makes sense that all we're going to do is just add. So in this case, when we start with x, this means shift 4 units to the right, which means we're going to go to x plus 4, and y here, we're going to shift 3 units down, that's going to be y minus 3 here. So we can see that the translation has a very easy thing to deal with here. Okay, so we're running a very straightforward transformations. Okay. Now, what I want to focus on here is this. So I want to take a look at, I want you to have a look at this picture here. This I found online, which I thought was pretty nice. As you can see, it's a rather nice photograph of footprints in the sand here. So if we focus on the feet, right? Let's take a look at the feet here. We got one here, one here, one here, one here, all these footprints all as we go. So I'd like you to take a bit and I'd like you to consider to yourself, what transformations do you see occurring here? Well, one thing we note is that because of the way the feet are, you can see here, this seems to have, the feet have different shapes here. One shifted this way, then left and right. So it seems like there's some sort of reflection here. In fact, there's going to be some sort of line reflection. So it appears that there's some sort of line, something like this, down the middle here. Now again, I'm drawing this approximately here because this is not perfect, but something like that here. There's some sort of line, especially if we look locally around here. There's some sort of line that we can seem to reflect this around, right? So we end up with something that looks like this here. We have a foot like this, right? But note that a reflection is not enough, right? Yes, we do have a reflection like this here where we have a hop like so. But there's also this idea that the footprints are sort of proceeding toward the back of the picture here. So we seem to have this as well. So we have a translation that heads in that direction as well. And note that, this sort of thing just keeps iterating over and over here. We have a reflection here to generate sort of our other foot here, right? Again, I apologize, my feet are not very good, I don't draw it very well. And then we have a translation like this, and then we do this again, we reflect in this direction and move like that, and then we reflect again and do that here. So it seems like we have this sort of composition of a reflection and a translation here. Now this, in this situation here, we're going to refer to this as what is known as a glide reflection here. So couple things to note about the glide reflection we can mention. A glide reflection here, we can define a glide reflection as a transformation that is a composition of two things. It's going to be a composition of a line reflection. So we're going to have a line reflection here. And we're going to have a translation. Now, a couple things to note about our translation here. If we take a look at this, right, our line reflection makes a lot of sense because we're going to be flipping this back and forth here. But now another thing to note about this is that in this situation here, note that our vectors, if you look at the vectors and look at them carefully, first off, the vectors should all remain the same, which makes sense because we're just iterating the same translation over and over again. But note that the vectors, as you can see here, I think you can see that they're running parallel to the line of reflection here, right? And it kind of makes sense, right? Because if let's say, for instance, that we had an anomalous vector like that. Instead of using the blue vector, the blue arrow here, for our translation, we translated like this. So I think you can see what would happen here if we kept going, right? So if we did this here, we do our reflection, and then our foot looks something like this here, right? Now our foot looks like that, and now as you can see, it's to the left of where the actual footprint is. Then if we do a big reflection like this, it goes like this here, we create our foot like that, and then we continue in that direction here. So notice how in this situation here, I think you can see that for something like this here, our footprints are going to end up further and further apart here, right? So we have something that looks like this here, and then we have our direction like so, and then we can do this again, reflect back there, and then just keep going. So instead of having a nice parallel footprints here, we have footprints that tend to that would diverge, and be rather painful to experience and actually trace yourself. So in this situation here, we can state that the glide reflection is a transformation that is a composition of line reflection and a translation that runs parallel to the line of reflection. Okay? So we note here that the glide reflection has that. So you have to ensure that the translation lies parallel to the line of reflection. In addition, and I think you can probably see this here, you can also see this in the textbook. Notice that I did the reflection here, right? Note that we didn't have to do that, right? I could have done this here, gone forward first, done my translation like that, and then reflect back. And then do this here, and then reflect back, and so on and so forth, like so, and keep going like this here, right? So the nice part about the glide reflection is that, and I think this is going to be another important thing here, for glide reflections, order will not matter, because you're going to end up in the same place. So the nice part about the glide reflection, even though it is a composition here, the order is actually not going to matter for glide reflections. So for instance, as an example here, we can consider a glide reflection to be something across, let's say, the line y equals x, and then we want to pick a translation vector that is parallel to, pick a direction that's parallel to y equals x. Well, y equals x is a slope of 1, so something that's parallel to that would be something like, let's say, 3, 3, for instance, right? We can have something like this here. And I think you can show, one thing you may want to consider as an exercise here, you can try to show that this and this will yield you exactly the same thing. You can try to show that these are the same. Okay? Not something for you to take a look at on your own.